So a month ago, Veritasium had dropped this particular video on his YouTube channel. So it's basically a probability problem, and actually, indeed, it's a beautiful problem on probability. So the question, I'm going to put the question. So the question is like, Sleeping Beauty is put to sleep on a Sunday, and while she's asleep, a fair coin is tossed. Now, if the coin turns out to be head, she's woken up on a Monday. But if the coin turns out to be a tail, she's woken up on Monday, put back to sleep, and awaken on a Tuesday. Okay, so now when she's woken up, she doesn't remember, whether she was woken up on the previous day or so. And the question asked to her is what does she think is the probability that the coin turns up head? Okay, so now in that video, he, almost concludes like having two solutions. One is 1 by 2 and the other is 1 by 3. Now, I will agree with the answer 1 by 2 if it was like she is put to sleep, woken up, and asked what the probability is. But in this case, it's not that simple. There is a distribution of conditions or events, and we call that conditional probability. Right? So, here we don't have a straightforward probability problem, it's a division of events. Okay, so the original question when she's woken up is like, what does she think is the probability that the coin turned up heads? Now, finding this might be a bit complex. So, what we are going to do is going to hit the complement tree of the head, that is the probability of finding the tails. Because if we do 1 minus the probability of finding the tail, we get probability of it being heads. Now, how do we find this probability of tail? So if you see, the only time she's woken up on a Tuesday is when the coin turns up tails, right? So if we are able to find the probability of it being a Tuesday on the day she's woken up, we basically associate it with the probability of getting tails. Okay, so cool. So in order to do that, we are going to use an experiment and analogy. So let's head back to that. So here's the experiment. So experiment is like we have two bags, bag 1 and bag 2, in short B1 and B2. And the contents of this bag are basically balls which are either red or black in color. Now the experiment goes like this. We have the bag 1 and we randomly draw a ball from bag 1 and transfer it to bag 2. And then we randomly pick up a ball from bag 2. Now talking about the contents of bag 1. Now bag 1 has red balls, one red ball and one black ball. Now the red ball in bag 1 is associated with coming up of a head on the coin, and that of a black ball is associated with coming up of a tail on the coin. Now if we go to bag 2, we have only n red balls, like there aren't any black balls initially. So we have n red balls and that is associated with it being a Monday. Okay, and now the black ball in bag 2, which is only possible when a black ball is transferred from bag 1 to bag 2, is that we associate it with being a Tuesday. So if we pick up a ball that is black in color from bag 2, we associate it with Tuesday. Okay, so this is the experiment, this is the event. Now, okay, this is the setup and the events, it's A and B. So the event A is the event where the ball drawn from bag 1 is black in color, and event B is the ball drawn is black from bag 2. Now, we only discuss about black balls here because see, what we actually have to find is the probability of it being, a Tuesday. So that's what our ultimate goal is, because then we associate it and we get the answer for the probability of it being ahead. Now if you see here, I did not specify the value for n. The reason for that is actually, if I try to explain that here, it will be much complicated and I don't want to do that. So as you proceed with the proof, there I will be specifying the value of n, and at that point you will be able to understand it much better that why do I give that specified value for n. Okay, yeah. So the ultimate goal in this one is finding the probability of of it being a Tuesday. Now look at the experiment. Okay, my handwriting is bad, I know that. But bear with, come on. Okay, so look at the experiment and we have associated the day being Tuesday with a black ball being drawn from bag 2. So if we find the probability of a black ball from bag 2, then we actually find out, the probability of it being a Tuesday. Now, in conditional probability, we give this probability of drawing a black ball from bag 2 as P of B by A. Now, if you know the theorem or the theory part, it's good. I'll just tell what this denotes. So this thing, P of B by B slash A, is actually the probability of B for a given event A. That is, event A has already taken place and we are finding the probability of event B. Now you expand this as P of B slash A is expanded as P of B intersection A divided by P of A. Cool. Now this upper part, right, P of B intersection A is expanded as P of A slash B product P of B divided by P of A. So this, let's call this equation the star. Okay, so now what we have to do is find the values of all this, right? Find these values, substitute and find P of B slash A. P of A. So we find A, and it's like probability of drawing a black ball from bag 1. We know the number of black balls in bag 1 is 1 and the total number of ball is 2. So sorted for A. Now we come here, the probability of B, the event B. So event B is drawing a black ball from bag 2. Now we know that this event A has already taken place, that is the black ball has been transferred to bag 2. So the number of black balls in bag 2 is 1 and the total number of balls in bag 2 is n plus 1. Now comes on the value of n. So here I take n to be 2. Okay, so now you could be stuck with the question that she's woken up on a Monday if it's a tail and she's woken up on a Tuesday like if it's a tail. So there is some distribution here again of the tail. So what about that? Because we are finding the probability of it being a Tuesday when tail comes up, but she's also woken up on Monday when the tail comes up. So there is some part of the probability that is given to Monday. So the value of n equal to 2 here compensates for both, because if you see, irrespective of whether it's a head or a tail, she's woken up on a Monday. That is, there are two cases here. One is the head and one is the tail. She's woken up on a Monday. And here we have associated a drawing of a red ball from bag 2 to be Monday. So hence the value of n here is 2. See, it's kind of an assumption here, because if I go to explain the actual facts behind this, it will take another 30 minutes. And I don't want to make this video that big. Okay, so that is why we take the value of n equal to 2 here. So substituting the value of n, we get 1 by 3. So that's P of probability of B. And now finally the probability of A slash B. Okay, so this is like B has already taken place. So what is the probability of A? So that is a black ball has been drawn from bag 2. And the only time when that's happening is when a black ball has been taken out from bag 1. So the probability here is 1. So substituting the values, so all these values in this star equation, we get P of B by A to be equal to 1 into 1 by 3 into 1 by 2. So this turns out to be 2 by 3. Now you don't need to worry about the part of tails that has been, given to Monday, that part, because that is compensated in n equal to 2. So here we have P of B slash A to be 2 by 3 and this is associated with Tuesday. So we get the probability of it being a Tuesday is 2 by 3. Now we have associated the Tuesday with coming up of a tail. So this is probability of getting a tail. So the probability of getting a head, my handwriting, yeah, 1 minus P of T, tails here, okay? So that's 1 minus 2 by 3 and that gives us 1 by 3. Now this is the reason why I have agreed with those people who said the answer is 1 by 3, because there's a proof here and it's a well settled proof. I don't think there's any actual assumptions, because even the assumption made here n equal to 2 is an actual fact, but due to time constraints I'm going to make it short. And yeah, so if you have made up till this end of the video, I appreciate that. And if you find anything sketchy in this, like you all have your own proof, do comment it below. I'll surely reply to them. Yeah, so this is the Samet guy.